Now, after completing the Otto cycle, let us now see another type of air standard cycles, that is the diesel cycle. So these two graphs are very important as before. This is the pressure volume PV curve. This is the temperature entropy TS diagram. So here in the TS diagram, as you can see, I have drawn a dotted line. This line was of the TS diagram of Otto cycle. To show the difference between the TS diagram of Otto and diesel cycle, I have drawn this diagram in a dotted line and the diesel cycle TS diagram as a plain line. And this is the PV diagram for diesel cycle. As before, let us define the processes. So the process 0 to 1 is the intake process. Intake process. Here the air valve opens and the piston moves outwards. Due to the moving of piston outwards, the expansion takes place and from the inlet valve the air goes inside. The process 1 to 2 is, as you can see, an adiabatic process and is the compression process. Compression process, which is adiabatic in nature. Process 2 to 3, that is this one, as you can see the pressure is constant, hence you can understand by this diagram that the nature of this process will be an isobaric process. This process is known as the combustion process. Combustion process. Here an important feature is that in case of diesel cycle, with the combustion process the fuel injection also takes place. This process is an isobaric process. Now the process 3 to 4, as you can see, is like the process 1 to 2. It is an adiabatic process and this process is known as expansion process. You can see the volume increasing, hence it is the expansion process. This is a reversible and adiabatic process. Process 4 to 5, as you can see here, process 4 to 5 is the blow off process as of the previous one. Where heat is rejected, that is Q2. And again the process 5 to 0 is the exhaust process. So with these definitions we have completed the diesel cycle definitions and understanding of the diagrams. Now we will proceed as before we have done in the Otto cycle with the important expressions. Now from the exam point of view, as I have already told for Otto cycle, we also have the important expressions for the diesel cycle. Let me write those expressions for you. The process 1 to 2, as we have seen, it's an adiabatic compression process. Hence, first of all, we write Q equal to 0 because it is an adiabatic process. So, the expression for del U becomes CV into T2 minus T1, and similarly, W will be minus of del U, that is equal to CV into T1 minus T2. Now the process 2 to 3 is combustion. This process, the del U will be CV into T3 minus T2, and the formula for W will be P into V. So we write P into V3 minus V2, and the formula for Q will be Cp into T3 minus T2. We have already seen in the graph that this process is a constant pressure process. Hence, W have become PV, that is P del V, that is equal to P into V2 minus V1, and it is Cp del T, that is equal to Cp into T3 minus T2. So going to the next one, the process 3 to 4. It is an expansion and it is also the nature of adiabatic process. Hence, first we make Q equal to 0. So the del U becomes Cv into T4 minus T3, and W becomes minus of del U, that is equal to Cv into T3 minus T4. The last one is the blow-off process. It is an isochoric process of constant volume. Hence, the work done will be 0 and del U will be Cv into T1 minus T4, and similarly the Q will be Cv into T1 minus T4. With this, we have come to the end of important expressions and the understanding of the graphs and processes of diesel cycle. Now, further will be the derivation of efficiency of a diesel cycle.